Okay, people, let's begin our beautiful, beautiful class. Welcome to your math class here in your Colegio Mayor dos Andes. Today, topic for today, applications for linear equations. The objective for today is to studying graphing's linear function using the economical linear expression with substitution method. It's so important that today we're going to pay a lot of attention because we're going to see to watch another topic so important. It's very important that you pay attention all the process that we're going to watch today. So let's begin with our beautiful class. Okay, let's go. we're going we was talking about solving system of linear equation in two variables. Okay, we was watching like we can graph some equations. Okay, but when we want to find the system of these equations, it's very important that we can find uh, another method that we can use for try to calculate equations an easiest form, okay, quickest. Because look at that, we're going to begin with this beautiful example. We want to solve the system of equation by graphing, okay. But look at that. If we want to begin with with our exercise, we have to copy the first exercise here, like x it's equal 3y minus 1. Okay, before that we begin our exercise, I want to say hello to Vale. Hello, Vale, how are you? Santi Poveda, hello, how are you? For Sammy Rios, Maria Jose Hermida, hello, Maria Jose Hermida, how are you? Santi Poveda, Sammy Rios, Juan Esteban Torres, hello, Vale is here, oh, hello, Vale. Sammy Rios, hello to everybody. Santi Barreiro, excellent. That you was was the first here in our math channel. Hello to everybody. You know that you are so special to me, and that every one of you are in my heart, in my soul, in my mind. Okay. Okay. Now let's continue. Okay. We're going to graph this equation, but look at that. We have x equal 3y minus 1. Okay. I'm going to put all in y terms, so I'm going to move this y to this position in negative form and the x to the right position in negative form. So we have minus 3y. Remember that I'm putting all the equation in y terms, okay? It's equal minus x minus 1, okay? Now I'm going to multiply all the equation by minus 1 to change the signs that are there, okay? So 3y it's equal x plus 1, okay? Now I'm going to move this 3 at this position, okay? 3 pass to the other side to divide x and 1, okay? So we have the equation y is equal x over 3 plus 1 over 3, okay? Now look at that we have slope, okay? Now we have all the slope here, okay? If we find the slope, look at that we have y. We're going to put here slope. Remember, when we are speaking about the slope, change in y and change in x, okay? The slope is here 1 and 3, so we have to move 1 and 3, 1 position and 3 positions, okay? But look at that. If I have to move it, I have to find the intercept with the y-axis. We have the intercept with the y-axis here. This intercept with the y-axis represents that I have to find this point on the y-axis. It's 0.3. In this case, the intercept with the y-axis is the 0.3, okay? 0.3. Hello, Lunita, how are you that you are there? Okay, so let's begin. Look at that. 0.3, okay? Move 1, remember, rise and run. Rise 1, okay? And run 3, okay? Look at that. You can find the second point here. Remember, this point is the intercept with the y-axis. It's 0.3. Okay, now again move 1 and move 3, rise and run. Look at that. Now rise and run 3. Look at that. So we have a graph in this form, okay? We have a graph in this form, okay? Now if we continue with the second equation that I'm going to put it in purple, okay, we have to put it again with y terms, okay, minus 2. So I'm going to move this 2x to the other side of the equality and change their sign, okay? So we have now minus 6y, it's equal minus 2x minus 2. In this case, I'm going to multiply again all the equation by minus 1 to change their sign. Now the new equation is 6y, it's equal 2x minus 2. Okay, excellent. Now I have to move this 6 to the other side to divide 2 and 2. Y is equal 2x over 6. Oh, excuse me, minus, I have to erase this one, minus, erase, okay. Oh, positive, because I have to change, yes, I changed the sign, okay, plus 2 over 6. Now we're going to simplify this expression. Okay, middle 1, middle 3, middle 1, okay, middle 3. Okay, now y it's equal x over 3 plus 1 over 3. Look at that. Now we have the same slope. Look at that. We have the slope. Okay. And remember, slope is a change in y to change in x. Okay. In this case, look at that. It's 1 over 3. And the intercept with the y-axis is the same. Okay. Look at that. So we begin here again. Okay. And move 1 and move rise 3, 1 to 3. Okay, look at that. Rise 1 and run 3. Look at that. We have the same point. So we have one line on the other one. Look at that. So these system equations are very, look at that. It's very strange, but why? It's for this reason. There are three possible outcomes when we graph two linear equations in a plane. One point of intersection. In this case, we have only one solution. Okay? Only one solution. Parallel lines that have no solutions. Okay? Parallel lines, no solutions. And infinite numbers of solutions when we have coincident lines. Look at that. In this case, we have coincident lines. Okay? Look at that. We have coincident lines. Look at that. The same slope and the same intercept with the y-axis. Okay? So, if there is less one solution, the system is considered to be consistent. Okay? But if the same define distinct lines, the equations are independent. Okay? So, look at this beautiful table that we have. The graph, but look at that. We have two linear equations, and this graph have an intersect. Two lines intersect at one point. Okay? Which number of solutions have in these lines intersect? The system of equations has one solution given by the point of intersection of this point. Look at that. We have one solution. Okay, look at that. One solution. Okay, one solution. What type of system is? In this case, it's consistent and the equations are independent. Okay, but we can find parallel lines. Look at that. We have parallel lines. If the lines are parallel, then the system of equation has no solution because the lines never intersect. Okay, so in this case, this type of system is consistent and the equations are independent. Okay, now what happened? Like in our example, look at that. We have here our example: lines coincide. If the lines lie on top of each other, then the system have infinitely many solutions. The solution set is the set of all the points on the line. Okay, so in this case, it's consistent and the equations are dependent. Okay, that it's very good. Okay, in this moment, Santi is saying me, okay, but if we find infinite answers, we can find different answers too. Yes, why? Because in this case, the lines doesn't have a range, okay? Doesn't have And domain of range. The domain and range are in this case infinite, are minus infinite, or infinite infinite, or minus infinite minus infinite. Okay? But look at that. Look at how in this case, in our example, we have a lines that lie on the other one. Okay? So we have infinite solutions to do to the minus infinite and infinite. Okay, the same at the right point. Okay, now look at all the process that we have to make. Okay, that we have to construct to try to find. Okay, to try and find this line equation. Okay, okay, very good. And Lunita is asking in this moment why different answers, because remember that you can take all the infinite numbers of minus infinite to infinite, positive, or and here to infinite and minus infinite. So it's necessary that if you're going to construct a function table using these equations, you're going to take all the points and coordinates from the line. Okay, it's for the reason. Okay, very good. Now we have to find, we have to study in this case one method easiest that we can resolve the solution of linear equations. In this case, we're going to learn about the substitution method. Another method that can be used of solve system of equation without the graph, we have to graph always, is the substitution method. Okay? To use the substitution, we first need an equation solved for one of these variables. Then substitute that new expression for the variable into the other equation and solve for the other equation. Look at that. Pay attention. That it's so important that you pay attention in this moment. Why? Look at this y. It's equal 3x minus 3. Now, like y it's equal to this number, we're going to replace it into this y. Okay? Okay, everybody? Now, look at that. We have first equation 6x minus 4 times, remember, now y, because y is equal to 3x minus 3, so we're going to put this number into the y structure. Okay, look at that, into the y variable. Y is 3x minus 3, so 4 it's multiply in this case 3x minus 3. Okay, very good, equal 10. Okay, equal 10. Now you have to multiply 4 and 3. Please remember, we have negative sign in this case. Okay, very good. Now let's continue. 6x minus time plus minus 4 times 3, 12x minus times minus plus 4 times 3, 12 equal 10. Okay, very good. Okay, now look at that. Now we're going to simplify. Look at that. We're going to move this 12 to the other side in negative form, and look at that. 6x and minus 12x are like terms. Okay, so now 6x minus 12x minus 6x equal, okay, 10 minus 12 minus 12. Okay, hello Manuel Rojas, how are you? Okay, now minus 6x, it's equal 10 minus 12 minus 2. Okay, now I'm going to multiply again all the equation by minus 1 to multiply to change their signs. Okay, so we have here 6x, it's equal to positive. Now remember, this 6 is multiplying the x, so we are going to pass it to the other side to divide the number 2. So the answer is x, it's equal to over 6. I can simplify middle 1 and 3. Okay, 1 and 3. So the answer is x, it's equal 1 over 3. Okay, look at that. We have the first equation here. Here we have the first equation with the first answer. Okay, look at that. That we simplify the equation. Look at that. We use the substitution. We substitute this case the answer of y into the y variable, multiply, okay, like terms, and simplify the expression. Now we have the x answer. So now we can take this answer of x and substitute to into any one equation. Look at the easiest form. Look at that. We have this. It's easy. Y it's equal 3x minus 3. But x it's 1 over 3. So we're going to replace it. Y it's equal 3 times 1 over 3. Okay. Minus 3. Okay. Very good. Excellent. Hello, Santi Poveda. Now, 3 times, remember that we are multiplying in this case fractionary. 3 times 1, 3. 1 times 3, 3. So we have y, it's equal 3 over 3 minus 3. Okay? Simplify the equation. 3 over 3 is 1. Y, it's equal 1 minus 3. Okay? 1 minus 3, y, it's equal, hello Techo, by 3000. 1 minus 3 minus 2. Okay, look at that. We have the solution of this system equation. The solution of this system equation is 1 over 3. This is over 1 over 3 and minus 2. Minus 2. Okay, look at now how we can substitute, use the substitution method to try to find of easiest form, okay, the answer of this system. Okay, I know there's longest, but it's not difficult. It's very, very, very easy. The only thing that you have to take account, to pay attention, is the use of the signs. Okay? It's necessary that you multiply the signs. Okay? Remember, first, put the y answer into the the first equation. Multiply. Simplify the like terms, okay? And later simplify the expression. Later with the first answer, with the answer of x, okay? Substitute this number, this answer, into the other equation, okay? And simplify the expression. Look at that. And we have in this case y and x, like the solution of this method. Okay, now and don't worry if you in this moment are saying, oh come on, I don't understand. Remember that this video will be uploaded in 20 minutes, and later you can watch it again and try to understand again with my explanation, and you can say, oh, it's because of this one. Okay, you can do it later of our direction or at the night, and you know that you can find the part video that you need in this case. Okay, remember we are using in this case the substitution method, which is the other thing that we have to do. In this case, we don't have to do for time, okay? But remember that the equations, all the equations must be graphed, okay? You have to graph, you have to graph this equation here and find the intercept with the y and x axis and find this interview. But you know that this intersect 1 over 3 and minus 2. You know that if you find the x, look at that. If x is here 1, going to relate x and y, okay? 1 over 3 is like here, okay? And minus 2, minus 1, minus 2. In this point, here, in this point, you can find the intercept of the first equation on the second equation. Okay, very good. Now, I'm going to read some comments in our chat. Okay, there's a I have 5 comments. Okay, very good. Luna says hello for 5,000. Okay, hello for 10,000. Okay, very good. Who's more? Luna. Oh, Santi. Give me a like, Santi. Okay, very good. Luna was really, yes. Can you simplify a division? Yes, you can do it, Santi Poveda. But remember that if you can simplify, you have to find factors, okay? Yes, we have our direction of 2, 3, okay? And the class finish 15 plus 2, okay? Excellent. Okay, let's continue. We have 20 minutes. In these 20 minutes, we're going to play something. I need that everybody go in this moment to a student.desmos, and we're going to try to practice with liners expressions. Okay, I know that in some aspects, like, oh, it's difficult. No, it's not difficult. You only have to put a little mind. Okay. So I go to hey students, go to student.desmos.com and type in, okay, please use this code in student.desmos and put it, okay, please later that you put the code appear another window and say what do you want, like using Google or without singing. Okay, please, at the second window, please click on without singing and put your real name. I need that everybody put your real name. The activity in this case have grade, okay? So I need that everybody will be in Desmos, okay, we're going to practice using some linear equations. It's not the exercise are not difficult, okay? The exercises are not difficult, but you have to put a lot of mind if you want to do it. So everybody, go to student.desmos.com and put and type in the code, okay? Please type in the code H5C AKX. Okay, please, everybody, go. I need that everybody go, please. You have 5 minutes. 5 minutes. Remember, go to Desmos. Okay, go to Desmos. I'm waiting for you. Okay, everybody? Okay. In this moment, we can find María José Hermida, Santiago Barreiro, Cristóbal León. Hello, Cristo, how are you? Valeria González, Manu, Paula Andrea Sp. Oh, hello, Vespi, how are you? María José Ibáñez, Vale, hello, Vale. Sammy Ríos, Camila Dicosio, hello, hello, Cami. Mariana Donoso, hello, hello, Mariana. Okay, let's continue with our activity. I need that everybody go to desmos.com and type in H5C AKX. Okay, remember that if you need this, if the second slide or the second window that open Desmos says like, okay, using Google, no, please put without singing, okay, without singing, and put your real name. Remember that this activity have grade, okay, okay, everybody, let's go. Hello, Marcus, how are you? Santi Santu. Okay, very good. Excellent. Remember that if you need to watch again the video in 20 minutes, you can watch it again and try to solve all your doubts if you have it. Okay. Okay. I'm going to close the window and max. Okay, to maxify the window. Okay. Now we have here María José Almanza, hello María Jo. Juan Esteban Torres, Santi Poveda, Annie, hello Annie, how are you? Okay, very good. Gabriel Revelo, you're two times. Why? Okay, I'm going to add student, okay? Luciana, oh hello Luciana, please say me hello. Okay, Lunita appeared two times, I don't know why. Okay, Checho, hello Checho. Excellent, very good. Remember that you have a challenge to do in this type of exercise, okay? Look at that. I can see all your challenge, how you're moving the line equations. You only have to move it. Very good. You have to change the value to change the structure, the line structure, okay? Very, very good. That you are doing this activity. Excellent. Congratulations. Okay. First challenge. Very good, Maria Jose Hermida, Santiago Barreiro. Please try it. You only have to change the values. Cristóbal Cerelón, what happened, Cristo? Maria González, excellent. Manu Rojas, excellent. Paul Andrea, it's trying. Okay, very good, Cristo. Excellent. Excellent. Remember that you have only to change the values. Okay, very, very good. Okay, we are 7 here. First challenge. We have 11. Okay, 11. Very good. Remember that you have to find. Very good. You have to change the values in our table function. In this table function, you have only to check the values that appear, and you have to put another one. So try to find the intercept with wall point. Okay. Juan Esteban Torres, yes, very good. You can do it in this form. Excellent. But remember that in this case, always you have to pass through the origin. So it's necessary that don't do a parallel lines because all the equations have to pass for the origin. Okay, it's not difficult. You only have to move all the equations in this case. Okay, very, very, very good. Burgos, what are you doing here? Again? Okay, okay, Burgos. It's because you are one class before, okay? For this reason, you are in another class. Come on, Marcus. What are you doing here? You have go to your class. Okay. Okay. Very good. Let's go. Very good. For who is this? Oh, Camila, because you're very good. You are doing a good process. Excellent. Please, Juan Esteban Torres, remember that all the equations have to pass for the origin. Santi Poveda, please remember that all the lines have to pass to the origin. Okay? Okay? All the equations have, all the graph have passed, must be passed from the origin. So it's necessary that you change the structure of our graph. Okay, it's fine, but remember that all the expressions have go to the origin. Okay, very good. Valeria Gonzalez. Oh, Valeria, excellent. You are doing so good. Excellent. Very good. Let's continue. Okay, let's continue. Manu Rojas said, help! Okay, Sammy Rivo say, help with the second, but I can't help in this case because look at that. I can see what are you doing. Look at Valeria Gonzalez, okay? It's excellent, Maria Jose Hermida. Wow, excellent, Maria Jose Hermida. You are working so good. Okay, let's continue. Excellent, very good. Continue. Okay, people, excellent. Maria Jose Hermida have to have a beautiful structure. Excellent, Maria Jose. Very good. I'm going to put the Maria Jose Hermida window. One moment. Okay. For everybody, if you want to see the structure of some lines, very good, Maria Jose. You are doing excellent. If anyone wants to see the line structure that she is putting on in this moment, you can check it. Okay, please, Maria Jose, put another decimals. That it's important because look at that. That some lines pass like a tangential on the blue points and the decimals cancel in this moment. It's wrong. So please, more at the center of the origin of the point. Okay. Very good. Excellent are you doing. Cristobal, you're doing good. But remember, Cristobal, that you have to pass all the lines from the origin. Okay? So it's necessary that you change the structure. Okay? Very good. Camila Di Cosio, excellent. Very good. Santi Poveda, George singing, excellent. Juan Esteban Torres, very good. Very good, Santi Poveda, that George singing the structure of our lines. Very good. Sergio is not here. Luna Sofia, Juan Esteban, very good. I'm moving. Mariana Donoso, remember that all the lines have passed for the origin. Look at that. It's like a star. You have to draw like a star. Very good. Okay. Excellent. Cristobal, it's fine your questions, but remember that all the lines have passed to the origin. So look at that, only the second are, is passed from the origin. The others ones pass from other points, have different intercept with the y-axis. In this case, all the lines have passed from the origin 0, the center of the middle of of our Cartesian plane. Okay, let's continue. Valeria Gonzalez, excellent structure. Sammy Rios, excellent. That you're doing very, very good. Excellent. Very, very, very good. Okay. Somebody sent me, Burgos, what are you doing here? And Burgos, fine, go. Okay. Very good. Luna said, help with the second. What happened with the second? Okay, you're going to change the exercise to second. And said, Paula Andrea, where are you? Where are you, Lunita? Annie, okay. Luciana, Luna, but look at that. The second is fine. Okay, or you say the second exercise have the first slide. Are you speaking about that? Okay, I'm going to find you, Gabi, Sergio, Luna. Oh, okay, Luna, very good. I'm going to see the process that you're doing in this moment. Okay. Okay. No, please erase all these parentheses. Okay, look at that. Please put like y is equal 0.3x and see what happened. Okay, put y is equal 0.3x and look at what happened. Okay, I don't know if I can put something here. A bill like yes. Okay, let me a moment. If I put y it's equal, okay, look at that 0.3x. I can put some lines. Okay, look at that. I can put some lines. That didn't appear. If I said check my work. Okay. Oh, look at that. Remember that you have put only check my work. Okay. Look at that, please. You have to move this one. You have in this case put the X and click on check my work. If you want that appear the liner. Okay, look at that. Very good. You are the second are fine. Line 1, line 2 appear right. Okay. So let's continue, Lunita. Okay. Okay. Vale Gonzalez say me teacher. Fine. Okay. Going to say oh Valentina. Hello. Valentina, you're doing very good. Vale Gonzalez, excellent, very, very good, excellent, Valeria, very good. Like always, you're working so good. Santiago Barreiro, do it fine, but look at that, you have a lot of lines with like a tangent with some blue points. Okay, Maria Jose Almeida, excellent work. San Cristobal Celedon, I don't know what you're doing. Okay, what are you doing? Okay, but look at that. If you put check my work, okay, appear, very good. Oh, look at that. Look at that, look at that. You have to move it, Cristo. Okay, please move it 3 equations. Because look at that, appear like a disorder. Look at that. You have to move some values. Okay, very good. Let's continue. Okay. Very, very good. Excellent. The way that you're working, I'm so proud of you. Very, very, very good. Okay, I'm going to see Valeria Gonzalez. Tell me, okay. Vale. Oh, excellent. Excellent exercise, Vale. Very, very, very good. Excellent. Okay. Who's more here? Okay. Who's right? Okay. Let's continue. Santiago Barreiro, excellent. Maria Jose Ibanez, what happened, Maria Jose? I know that you're working. Santi Poveda, Sergio, wow, Sergio, you're working very, very good. You're working so good. Okay, let's practice. Don't worry if some lines doesn't appear. Don't worry about that. Okay, you can do it. Okay, Nicordonias, very good. Excellent. Luciana, where are you? I don't see you. Excellent. Let's continue. Very good. We have only 2 minutes more, so I'm going to put pause in this moment. Okay? Why? Because we're going to finish our class. Okay? Remember, I'm going to put this beautiful, beautiful table. Remember that when we are graphing the linear equations of two or more linear equations, in this case, two linear, we can find different types of solutions. One of them is two lines intersect at one point. In this case, remember the number of solutions if the line is intersect the system of equations have one solution given by the point of intersection. Okay, so in this case, the type of system is constant and the equations are independent. Okay, the second one is the parallel lines. If you can see, we can graph, okay, and draw the line, and the answers can be a parallel lines. If the lines are parallel, then the system of equation has no solution because the lines never intersect. So in this case, the type of systems is inconsistent and the equations are independent. Okay, because we can find the lines are independent of each one. Okay, now what happens if the line coincides? Okay, if the lines coincide, if the lines lie on top of each other, then the system has infinitely many solutions. Okay, because it's one on the other one. The solution sits of the central point of the line. Okay, so in this case, the equation is consistent and the equation are dependent. Okay, remember that we are using and we are studying and we are watching the substitution method. It's necessary that you see the video again if you have some doubts. Okay, in 20 minutes the video going to be again a lot. Please check out the exercise that we uh, work today. Okay, and please no more for today. We have class tomorrow again, so prepare because we have tomorrow another activity for grade. Remember,